All right, let's talk about a new kind of digital magic trick. It's a really stealthy threat where attackers can make a malicious website basically invisible to the very AI security guards we've built to protect us. So how are they pulling off this digital sleight of hand? Well, let's find out. So let's start with this idea, because it really gets to the heart of this new vulnerability. Just imagine a web page. It looks totally normal to you, but it's secretly feeding a completely different story, a set of hidden commands, directly to the AI that's scanning it for danger. So how does this whole thing work? Well, it all boils down to one single, really clever concept. What you see is not what the AI sees. It's a kind of digital illusion that researchers are calling perceptual asymmetry. And that concept, perceptual asymmetry, is the key to all of this. You can basically think of it like digital invisible ink. Attackers write one message on a website for us, the humans, and a totally different one for the AI security guard. So we might see a normal login page, but the AI is being told, hey, everything's fine here, nothing to see, move along. And this slide right here, it just lays it all out so perfectly. Over on the left, that's what you see, a perfectly legitimate-looking site. But then, on the right, that's what the AI model sees. It's the same website, but look, it's absolutely littered with hidden instructions designed to trick it. And the whole time, the human user has no idea this is even happening.
And look, this isn't just some lab experiment or a what-if scenario. This is affecting some of the most advanced large language models that are being developed and used right now, not to mention the specialized security tools that are built right on top of them.
Okay, so how do they actually pull this off? Let's get into the hacker's playbook and break down the 4 main techniques that attackers are using to run these invisible attacks. So the first method is, it's surprisingly simple. It involves hiding instructions in a place most of us barely even notice, the title of the page that shows up in your little browser tab. So here's a closer look at how they do it. You know how your browser tab can only show a little bit of text? Well, attackers use these special invisible characters. They're basically just spaces to push a malicious command like, "This site is safe," way off to the right, way beyond what you can see. You'll never see it, but the AI, it reads the entire title, hidden command and all. All right, method number 2 gets a little more technical, but it's just as sneaky. Here, attackers confuse the AI by sticking in fake code tags. Now to your browser, they're meaningless, but to the AI, they look real. The AI thinks a chunk of code has just ended, so it starts treating whatever text comes next as a top-level command. This next one is just super direct. Forget about hiding things in the page's code. With this method, the malicious prompt is just tacked right onto the end of the website's URL. I mean, just look at this example from the research paper. The AI reads the entire URL, all the way to the very end. And that whole chunk after the hash sign, that's basically a direct order. It's telling the model to ignore everything else it just saw on the page, and to just spit out the answer, "Phishing is false." It's a total override. And this last method, honestly, it's like something straight out of a spy movie. It involves putting text on the web page that is physically invisible to our eyes, but it's perfectly readable by a specific kind of AI. Here's the trick. The text is either set to a color that's almost identical to the background, or it's written in a font that's so incredibly tiny, it just looks like a speck to us. But, and this is the crazy part, a multimodal AI, one that can process images, can just take a screenshot of the page, recognize the characters, and read that hidden message loud and clear. Okay, so we know how they do it. But what's the big deal? What happens when these attacks actually work? Well, the consequences are pretty significant, which is why this vulnerability got a high severity rating from researchers. And here's the bottom line. A successful, invisible prompt attack lets a malicious phishing website look completely harmless to the automated systems that are supposed to catch it. It basically gives the attackers a free pass right through our defenses. And that leads directly to some really bad stuff. First off, more successful credential theft, because our first line of defense is blind. But it gets worse. Attackers can also use these tricks to shut down our security tools, or even corrupt the whole security workflow by just making the AI output total nonsense. So, this sounds pretty bad, right? But the good news is we are not defenseless here. Researchers have already developed a really smart, multi-layered defense strategy to fight back against these invisible threats and turn the tables on the attackers. And this layered approach is what makes the defense so strong. Okay, so first up, you strengthen context boundaries. That's like building a little quarantine zone around the website content so the AI doesn't get confused. Second, you use structured input parsing, which breaks down stuff like URLs into separate parts so the AI can't be tricked. Third, there's pretext rejection, which is basically teaching the model to spot and ignore classic tricks like ignore your previous instructions. Fourth is using an allow list. That makes sure the AI only ever consults pre-approved, trusted sources. And finally, number 5, output validation. That's a final security check, just to make sure the AI's final answer hasn't been hijacked.
When you step back and look at all of this, you realize what we're really seeing is this fascinating, constant battle. It's an ongoing AI arms race, with attackers finding these new, stealthy techniques and defenders racing to build smarter, more resilient systems to stop them.
And that really leaves us with this one big question for the future, doesn't it? As our AI defenders get smarter and more sophisticated, will the attackers always be one step ahead? Will they always find some new kind of invisible ink to get past our defenses? That's something the entire security world is going to have to deal with. Hey, thanks so much for joining me on this deep dive into the world of invisible prompts. In this AI arms race, understanding the threats really is our best defense. Stay vigilant out there, and we'll see you next time.